Welcome to the DIY Honda Garage channel. DTC B18A9 refers to left BSI radar unit voltage input high, a diagnostic trouble code for the 2011 to 2017 Honda Odyssey. The acronym BSI stands for Blind Spot Indicator, which plays a critical role in enhancing driver safety by detecting vehicles in adjacent lanes, particularly in blind spots. The radar unit itself is typically located behind the front bumper and is crucial for the functioning of various advanced safety features that help prevent collisions. An elevated voltage input can indicate that the radar unit is receiving excessive voltage, potentially due to battery or charging system issues. It's essential to pay attention to any patterns of this error occurring after jump starts, suggesting a connection between the code and battery voltage inconsistencies. This guide will provide a troubleshooting pathway to effectively diagnose and address DTC B18A9. DTC B18A9 indicates a fault in the voltage input for the left blind spot indicator BSI radar unit of the Honda Odyssey. This radar component is essential for monitoring the vehicle's surrounding environment, reducing the likelihood of accidents by alerting the driver to vehicles in adjacent lanes. The radar unit is typically situated behind the front bumper, centrally located to provide comprehensive coverage of the vehicle's sides. The importance of this unit cannot be overstated, as it integrates with advanced driver assistance systems, ADAS, like lane change assistance. Improper voltage input, particularly at a high reading, can lead to malfunctioning radar operations and negative impacts on the vehicle's safety functionalities. Recognizing the correlation between high voltage signals and the overall health of the vehicle's electrical system is crucial for effective troubleshooting. Several possible causes can trigger DTC B18A9, primarily revolving around electrical system irregularities. A faulty charging system is a top suspect. It can lead to overvoltage conditions that affect the radar unit's performance. Such issues often arise due to failing alternators or damaged electrical wiring, which can cause inconsistent battery recharge. Battery issues themselves can also play a critical role. An aging or defective battery can deliver improper voltage to the radar unit, leading to diagnostic errors. Another significant factor is the presence of loose or corroded connections that may intermittently disrupt power flow, leading to fluctuating voltage readings detected by the radar unit. Collectively, it's vital to methodically assess each of these potential causes during diagnosis to ensure a thorough and accurate repair. When DTC B18A9 is active, there are specific symptoms that may manifest within the vehicle's operation. One primary symptom is the activation of warning lamps on the dashboard, which alerts the driver to potential issues. Additionally, the radar system itself may exhibit malfunctioning behavior, failing to detect vehicles in nearby lanes or providing false alerts. The vehicle may also show inconsistent detection alerts, reducing the system's reliability and thus compromising driver safety. These symptoms underscore the necessity for prompt diagnosis and repair, since they not only affect the functionality of the radar unit, but also the overall safety of the vehicle. Effective troubleshooting can identify the underlying issues and restore the proper functionality of the BSI system, greatly improving driver confidence while on the road. The first step in troubleshooting DTC B18A9 involves clearing the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. The HDS is a specialized tool designed for Honda vehicles that allows technicians to interact with various electronic systems and troubleshoot faults efficiently. Clearing the DTCs resets the vehicle's engine control module, ECM, essentially providing a clean slate for observation of any new codes that may appear. After this step, It is crucial to start the engine and allow it to idle for a minimum of 20 seconds. This brings the vehicle's systems online and allows the HDS to gather relevant data points regarding potential faults. Following the warm-up period, check again for any DTCs using the HDS, as the reappearance of code B18A9 would confirm that the problem persists. This systematic approach helps to ascertain whether the issue is an intermittent fault or a persistent one needing further investigation. In the second troubleshooting step, after clearing the DTCs and restarting the engine, it's vital to recheck for the reoccurrence of DTC B18A9 using the HDS. If the code is indicated again, this confirms a persistent issue with the left BSI radar unit, suggesting that deeper diagnostics are required. Conversely, if DTC B18A9 is not shown, it may suggest an intermittent failure or a temporary glitch within the system, meaning the electrical components may be functioning correctly at this moment. However, it remains essential to further investigate any loose or poor connections, as these could very well lead to future errors or malfunctions, even if no issues are present right now. It's imperative to note that intermittent failures can be tricky and need attentive observation to prevent unexpected breakdowns later. Thus, follow-ups on intermittent error occurrences are advised to ensure reliability and safety. The third step in troubleshooting DTC B18A9 involves turning the ignition switch to the lock 0 position. This is a necessary measure to ensure that all electrical systems grid shut down safely and that there are no risks of short circuits while conducting further tests. Once the ignition is in the lock position, proceed to test the battery. A reliable multimeter can be used for this purpose, taking note of the voltage reading. A healthy battery should typically show a voltage between 12.4 volts and 12.7 volts when the vehicle is off. Additionally, ensure that the battery terminals are tightly connected and free from corrosion, as these conditions can also impact performance. If the battery checks out as functioning correctly, it leads to the next phase, which involves replacement of the left BSI radar unit. However, if the battery indicates weakness or failure, that'll necessitate immediate battery replacement to restore proper vehicle functioning. In this final troubleshooting step for DTC B18A9, assess whether the battery's condition is satisfactory following the testing in the previous step. If the battery is functioning correctly, then the focus should shift towards replacing the left blind spot indicator BSI radar unit itself. The radar unit may be compromised, leading to inaccurate readings and subsequent high voltage input errors. On the other hand, if the battery is found to be defective, it must be replaced as a priority. A failing battery can directly influence the voltage supplied to various electronic components, including the radar, leading to systemic issues such as this DTC error. Ensuring that both the battery and the radar unit are in good working order is crucial for system reliability. After replacing the necessary components, further testing for DTCs should be conducted to ensure the resolution of faults and restore the full functionality of the blind spot detection system. After all necessary repairs have been made for DTC B18A9, it is crucial to undertake a final verification process. Start by testing all replaced components, verifying their proper installation and functionality. After confirming the physical connections and operational integrity, recheck for any DTCs using the Honda Diagnostics System HDS. This step is critical as it confirms whether the repairs have effectively addressed the issues. Ensure that the left BSI radar unit is now functioning appropriately, with no additional error codes related to radar or charging systems. By confirming system functionality, you can be confident that the vehicle's safety features, particularly the blind spot detection, are back to optimal performance. Carrying out this final verification ensures all repairs are validated, providing peace of mind for the driver. Preventive maintenance is key to avoiding issues like DTC B18A9 in the future. Regularly check the battery condition. Look for signs of wear or diminished performance. Ensuring the battery terminals are clean and effectively connected can greatly reduce the risk of intermittent electrical failures, which may lead to the radar unit errors. Additionally, routinely inspect the charging system for proper functionality. An inefficient or faulty charging system can create detrimental effects on all electronic systems, including the BSI radar components. Regular inspections and proactive maintenance can significantly extend the lifespan of components and prevent unexpected failures on the road. By following these preventive maintenance tips, you create a safer driving experience and decrease the likelihood of encountering DTCs like B18A9. In conclusion, understanding DTC B18A9 and its implications is vital for maintaining the safety-focused features of the Honda Odyssey. Knowledge of the left blind spot indicator, BSI radar unit's role, shows the importance of this component in collision prevention and overall driver safety. Prioritizing regular maintenance checks for both the battery and charging system allows you to circumvent potential issues before they escalate. The step-by-step diagnostic approach described in this guide ensures that all angles are covered, leading to accurate and effective repairs. By diligently following these steps and conducting post-repair checks, you can enhance the longevity and reliability of your vehicle's electronic systems. Maintaining vigilance over these components not only promotes safe driving, but fosters a deeper understanding of your vehicle's intricate systems. Please like and subscribe to the channel. See you next time.